Hello everyone, welcome back. Still on energy. All right, from our previous class, we discussed about energy, okay, and the conservation of mechanical energy. Right here, what I have on the board is questions. All right, look at these questions very well. We are going to solve them one after the other. So, solution. Let's start from one. A constant force of 40 Newton acting on a body initially at rest gives it an acceleration of 0.1 meter per second square for 4 seconds. Calculate the work done by the force. Okay, the first thing we need to do is to bring out the parameters out. So bring out the parameters. Okay, let us bring out the parameters. It has a force. So therefore, the force is equals to what? 40 Newton and acting on the body initially at what? Rest. Initially at what? Rest. Okay. Acceleration. Acceleration is what? 0.1 meter per second square. While the time is what? 4 seconds. Calculate the work done by the force. Okay. Calculate the work done by the force. We know that work done is equals to what? Force times what? Distance. All right, force times distance. So we have the force, but we don't have the what? Distance. All right, how do we get the distance? Since the body is in motion, we are going to use the what? Equation of motion. So therefore, we use the equation of motion to get the distance. Use the equation of motion to get the what? Distance. So the distance, u is what? The initial velocity is what? 0. So 0 times time here is what? 0. This is out of the game. So we have 1 over 2 times what? A. What is A? A is what? 0.1 times what? Time raised to the power of 2. Time is what? 4 raised to the power of what? 2. So this is x equals to 1 over 2 times 0.1 times what? 16. Okay, 2 into 16 is what? 8. So the distance is what? 0.1 times 8 is what? 0.8. So the distance is 0.8 meter. So since we now have the distance, we now equate it, substitute it into what? Work done. So work done is what? Force times what? Distance, which is equals to force is what? 40 Newton, and the distance is what? 0.8. So work done is what? 32 joules. So this is the what? Work done. All right, we solve for what? 1. Let's go to what? Number 2. Okay, question 2 says a ball of mass 0.1 kg is thrown vertically upward with a velocity of 10 meters per second from the top of a tower 10 meters high, neglecting air resistance. Calculate its total energy just before hitting the ground. Okay, let's do the same thing. We bring out the parameters out. So we have the parameters. Question 2. The mass m is equals to what? 0.1 kg vertically upward. Okay, a ball of mass is thrown vertically upward with a velocity. That is the starting velocity. U is what? 10 meter per second. 10 meter per second. Okay, from the top of a tower, 10 meter high. So the tower height is equals to what? 10 meter. Neglecting air resistance. So therefore, we now calculate the what? The total energy just before hitting the ground. Okay, let me illustrate this thing using what? Diagram. Okay, if this is the what? The tower. This is the tower. And let's say the body is here. This is the body, and the body was thrown up. The tower is what? 10-meter high. 10-meter was thrown up. So we don't know the distance the ball went to. So we don't know the distance from here to where the ball is. Thrown vertically upward. Okay. With a velocity of about 10 meters per second. And we want to calculate for what? The energy, the total energy just before hitting the ground. Remember our previous class, we discussed about conservation of mechanical energy. Mechanical energy from maximum height is the same at what? The ground level, maximum height and the ground level, between maximum height and so on and so forth. The mechanical energy is the same. So if we get the energy the ball possesses at maximum height, we also have the energy the ball is going to possess at what? The ground level, just before hitting the ground. Okay. So what you are going to do is to calculate for this distance from where the ball is to here, and then we add it to the tower distance, to the tower height, to get the what? Maximum what? Height. And once we get the maximum height, we just go straight to what? The gravitational potential energy, and then we have the what? The total energy. Because at maximum height, total energy is what? Potential. Okay. So maximum height. So you know that at maximum height, the total energy right there is equals to what? Potential energy, which is what? Mg what? H. So let us get the what? Maximum height. Okay, to get the maximum height, we use the what? Equation of motion. Equation of motion under what? Gravity. But in this case, it is what? Against gravity. That is what? Going up against gravity. So it's going to be what? We are going to use the negative sign. V square u square minus 2gh. So the initial velocity, which is u, initial velocity, that is the starting velocity, is what? 10 meters per second. And what? V, velocity as maximum height, is what? 0. So therefore, this is what? 0 equals to what? 10 raised to the power of 2 minus 2 times what? G is a constant value. We use 10 for G. 10 times what? The height. So therefore, this is 0 equals to what? 100 minus 20 watts H. So we take it to the other side. This is what? 20 H equals to what? 100. So therefore, we divide both sides by 20. 20, 20, and H is equals to what? 5 meter. So therefore, from this place to here is what? 5 meter. So if I add additional 5 meter to what? 10 meter, the maximum height will be what? 15 meter. So our maximum height is what? 15 meter. So let us calculate the what? The total energy at what? Maximum height. Total energy at maximum height, which is what? The gravitational potential energy, which is MBH, is equals to what? The mass of the body is what? 0.1 times what? G is 10 times what? The maximum height, which is what? 15. 0.1 times 10 is what? 1 times what? 15, which is equals to what? 15 joules as the what? Total energy. So this is the what? Answer to the what? Question. Okay, we'll come to the end of this section. I remain your favorite tutor. Please subscribe to the channel. God bless you.